Good morning, everyone. Myself Nishchay. I'm from EC department. I'm here to give you a brief introduction about smart farming application. Now, as you think, what is smart farming application? Smart farming application is nothing but like maintaining a server base or database, like how much fertilization is going to the farming field, or how much water is going to the farming field, and monitoring the continuously in the day routine, and storing the details in a cloud format using IoT. We use the cloud thing is thing space, where we store the database, so that at the end of the day the farmer gets can go to this Gmail account and go through the, like, how much fertilized going to the farming field, or how much like how much water is going to the farming field, what is the soil's temperature at that duration or time being when the water is going, and what is the humidity or temperature at the time being for fertilization purposes. Now these are the things which we are going to build. Now our group members are Kishore, Abhilash, Shridhar and myself Nishchay. And now we are at the end of this video, I'm going to show you a small video clip of our project prototype, and the different parts of project will be segregated each other, like software basis is taken by the Kishore, and connection part is taken by the Shridhar, and hardware part will be taken by the Abhilash. And now each of them will explain their own area and what they learned in that area. And my area is comes under the connection and hardware part, where I'll be taking a few minutes over there by explaining the components and the hardware, how it works, and how that process we are going to connection, how the connection we are going to give, and how it works. I'm going to explain over there, or we are going to expand over there. Now, as the farming field is day by day, in the India, farming field has been 58% for farming is done over 58% in India. Now, at the farming field, many of the crops are being growing. A farmer cannot maintain properly. Like, if he think he has too many farming fields, he cannot maintain properly day by day. So we use this application to build he can maintain his farming field anywhere, wherever he wants, wherever he wants, whenever he wants, in his mobile application, and wherever. It is user friendly, and it's very efficiency to use, and very easy to use. And
Here I am explaining about component used in our project, Genino UNO. It is an open source microcontroller board based on microchip at a Mega 328P microcontroller and developed by Arduino. The board is equipped with set of digital and analog input-output pins that connects to various expansion boards and other circuit. It is the brain of system, and it takes monitors soil moisture level, water level in tank, and also controls the motor circuit. Communicates with web browser and Node MCU. Flash memory is used as program memory inside the microcontroller. SRAM 2KB is used for a computer's cache memory. Node MCU ESP8266 breakout board. The Node MCU is an open source IoT platform. It runs on ESP8266 Wi-Fi system on chip. The adapter for ESP07 and ESP12 ESP266 Wi-Fi module. The microchip with full of TCP and IP stacks, and it has RISC microprocessor core based IEEE 802.11 is used for communication for wireless LANs. Ultrasonic sensor HCSR04. It provides 2 cm to 400 cm of non-contact measurement. The accuracy up to 3 mm. It prevents inconsistent bouncy data. It operating voltage 5 volt DC and operating current 15 milliamps. The measuring angle is 15 degree. Soil moisture sensor. It measures the moisture in soil and it has exposed pads function as probes. The temperature sensor are HT03. The humidity and temperature sensors are used. The single wire digital interface is used in this sensor. Submersible motors. The submersible pump are used in this motor. The voltage is 12 volt DC. The current is 400 milliamps. The maximum lift of motor is 3 meter. The relay module L289H bridge module. It has 5 volt DC to 35 DC. The onboard 5 volt regulator is used in this module. 2 submersible motors of 12 volt are driven by this module.
Hi all, in our project, my role is circuit connection and field implementation. How we implemented in our project in the field. Now I am going to explain. Now I am going to explain about circuit design and circuit design. I mean, what are the components we use and how circuit we done in this project. Now I am going to explain. We are using both hardware requirements and software requirements. You are using a Genino board, Node MCU, ESP826 breadboard, and sub reusable motors and L289H bridge modules and temperature sensor or to use to sense the temperature and humidity sensors and soil moisture sensor. Another one is ultrasonic sensor. And software requirements are Arduino IDE for Arduino board. Explain about how we done circuit design. Now I am going to explain. This is our circuit connection. We are using 9 volt battery and 2 motors to pump the water level, and these 2 motors are connected to the relay module. Okay, for connecting the motors. Now you are connecting to the temperature sensors and soil moisture sensors and ultrasonic sensors to the field farm field to sense the temperature and soil moisture soil and ultrasonic sensors to take the data from the field.
Now, coming to the connection part, as my friend told, we are using 2 ultrasonic sensor, one DHT22 sensor, which is also known as a temperature sensor or humidity sensor, and 1 soil moisture sensor, and 2 submersible pump, and Arduino and Wi-Fi module, which is ESP8035 part, like MCU module. Now, think. A soil moisture sensor is in the soil. Soil moisture sensor is in the soil, and the temperature sensor, humidity sensor is on the next to the soil, but it is not in the ground. It is temperature or humidity. It's the surrounding part of the plant. It should sense the temperature or humidity. Now, when we dump the program into the Arduino, first like 10 seconds the soil sensor will go turn off. After 10 seconds it resets its own module and go start sensing the temperature. Now, how it senses the temperature? This question plays a main role for everyone. Now, from think if when the temperature I told first it turns off for 10 seconds, we call it like that from from temperature value 0 to and continue for 60 seconds. 60 seconds we get after deload again turn off. It continues from it starts from 0. When the temperature value think it is coming to 400, suddenly it jumps to 700 degrees Celsius in soil sensor. The duration between the 400 to 700, that's the duration we are like in that duration between the durations, we take the threshold value. We also call it as a soil threshold in the program. And same thing applies for humidity and temperature sensor for DHT22. DHT22, we take the threshold value like that and sense the prototype. Whenever the threshold value or the sensor value goes lesser than the threshold value, or it is whenever it is not equals to threshold value, then the water pump or submersible pumps turns on to the farming field. So our farming field for fertilizers or fertilization or water purpose, watering purpose. And whenever the water turns on, the data will be stored. At this time, the temperature of the plant or soil content, soil water content is very less. It takes the time note, and the water passage of the water at that part. It takes the time of both of it and feed it into a database and stuff which we store in the cloud. It is fully automated, where the farmer can go anywhere and use this automated process at any time, any place, anywhere by opening his own cloud. And even he can control over from cloud basis of the system, whether the system should go turn off or turn on, or whenever is not there, whenever is in farming field, the system he can turn off by his own, or whenever is going outside the farming field, he can turn on automatically. So the system takes care from that time. Now this is our farming like connection part, and thank you.
This is Kishore. In this project I took the part of programming. For programming we used Arduino development environment. So in Arduino, the data will be taken from the field to the Arduino, and the Arduino will do the calculation, and it will get connected through Node MCU. It will get connected to the Wi-Fi, and from Wi-Fi we'll send data to the required person or a specified person. So how it does is the Arduino takes the readings from the sensors at a regular interval. We fixed it around 2 seconds. So it will check the humidity, temperature, soil moisture, everything, and based on that conditions we have certain threshold values. So based on that threshold values, the Arduino will turn off or on the motors based on that values, and at the same time it will send the data to the cloud. For cloud to display the messages, we use ThinkSpeak. So ThinkSpeak is very convenient and easy to use by just taking the API write key to be specific. So the data will through Wi-Fi, the Arduino will send the data at regular intervals to the ThinkSpeak. We made it around 15 seconds. Every 15 seconds the data will be updated to the ThinkSpeak, and we have written a program separately for a Node MCU for Wi-Fi connections and check for the availability of the server. So we developed it on the same Arduino environment, and at the same time updating in the ThinkSpeak, we used Blink application. So it is also a convenient method for the IoT applications. So the Arduino also sends the information to update the information on the Blink app continuously. So how our project works is the Arduino will take the sensor values from the field, and we have specified threshold conditions specified in the program. So based on that, the Arduino will check frequently the conditions. We have specified it around 2 to 3 seconds. So at every 2 to 3 seconds, the Arduino will check the condition, like what is the moisture level of the soil, or does it need water, or it is already in saturated level. So it will check and it will send the information to the motors. That is, it will turn on and off the motors, and this at the same time the information will be sent to the ThinkSpeak cloud, so where the farmer can visualize the data and at the same time the data is sent to the mobile application also. So he need not to be present in the field every time, so he can fix the time at what time he should come to the field, and he can regularly monitor the field sitting in other place of the thus being required internet connection for both the Arduino and this mobile. So for internet connection to be specified, we used Node MCU for connecting the Arduino to the cloud. So Node MCU is a Wi-Fi enabled, so we can use Wi-Fi. So we used Wi-Fi to send information to the cloud, and from the cloud the farmer can get the information wherever he present or which part of the world, so he can easily monitor his farm field. So this is about the working of our project.
Welcome back. As my friend told, what are the hardware parts we are using in our project, and now it's time to end. I am going to tell that advantages of our projects. It's less usage of time is less, and good amount of fertilizers will be sent to the farming field, and there will be no wastage of time, and user friendly, eco friendly. These are the advantages.